or in Saudi Arabia or North Korea.
But even born in America, we got.
I mean, someplace they think of as other already.
I'm just saying they
definitely even in America.
They don't even recognize it in their own freaking world. We've got $17 billion worth of debt.
Or town.
Well, okay, it's not a fantasy that somebody has to pay that in the future. Okay, that bomb doesn't blow up in their face.
They don't feel a connection to it.
It blows up in the future's face.
Yeah.
I mean, how can you sit there and discount their existence? How can anybody sit there with a straight, logical face and say it's okay for them to get blown up, but it's not okay for me to get blown up? I mean, you can't get any more not in my backyard than the bullshit people are
I know,
doing.
at the same time, we're still in a society that's all that. But think of the children. We're
Exactly.
just so fucking contradictory in what we do.
It's just absolutely a lie, right? I mean, it's just a lie. They're thinking about their children, and they're figuring, I'm going to be strong enough to be there for my kids. And that's all that they're thinking. That far, like I said, don't even think about their own kids' mortality and all this other kind of crap that goes on. You know, so I mean, you know, there's so much. That's what I mean by the map of your people's lives. Your life is a lot more complicated than the crap they taught you when you were a kid. You know, the bullshit you were fed by the Flintstones is not fucking life on Earth. It just isn't. We have to go up with a better narrative than SpongeBob.
Well, my other theory has always been that really, like artists, like politically, if we could make a world. But then I found how crazy and psychotic all artists are. But I still think they're on a route, because, I mean, it's one of the few things where people get inspired to an actual new way of looking at things and placing themselves in the universe.
It's another mechanism, though. I mean, any kind of distortion. So, I mean, whether you're distorting to, like Einstein, whether you're saying, okay, I'm going to pretend to ride on a light beam, you know, and so that's a procedure you go through. And artists are doing the same kind of thing. They're basically just playing with something, saying, well, what's the contrast, or what's the manipulation? If I do this, if I distort that, does this do something, you know? So it's almost a mechanical process also of losing yourself by distorting things, changing how you react. You know, it's like walking a wobbly fence or something, and you deliberately make it wobble, you know, to force your balance. You know, but that's all we're really doing is just reacting. But, you know, depending on what your objective is, it's just a different kind of creativity. You know what I'm saying? So in a way, Einstein was an artist. You know, because he had to, he had to break it to make it.
Yeah, absolutely.
You know, he had to break the rules.
No, and he was treated like that too. They ignored it.
He had to completely break the rules to be able to see it for what it was, because if you went by the standard model, you weren't going to see it.
Well, and the weird thing with Einstein, I've simplified a bit, but pretty much all his amazing stuff was when he was still a patent clerk.
Which is disappointing.
And then when he was a professor, it did have the effect he was worried about when he was young of, you know, you're with a bunch of other geniuses. It's clear to see they're geniuses, and how could that not be? You know, he's not so egotistical that doesn't have an impact on him. He didn't follow what other people were saying, but he also couldn't escape it.
That's the weird value of Einstein, though, is because I think as a philosopher he matured. You know, so later in life as a philosopher, I thought he was really good. You know, he's really eloquent. You know, and yeah, it's just kind of funny that he was really good as a scientist young, and he became a philosopher later. And so it's like those had two completely different values. But yeah, he got so lazy, from my perspective. You know, to think.
So this is video, the last 20 minutes of a video where I, on the way to Maine, stopped in Inmendham, if you're curious. And so Gary and I were in the same IRL space.
That, you know, the last 30 years of his life, he was just kind of naysaying, but he wasn't saying anything.
He tried again and again, yeah, but
you know.
But it got pretty sad. Like when I read his biography, I was surprised at how bad it got. It got to be like, you know, he was dealing with fellow scientists that were on the equivalent of climate change deniers or something. And maybe there's a grain of truth in that. Yeah, I mean, I do believe there's a grain of truth in the Einstein case, but it was just kind of funny. I mean, he was a very, you know, everybody that was carrying the helm of modern physics basically had gone on in this other direction, and his allies had become a very small set of people. That would react, for example, to reputation, and you know, of course, I'll be happy to be on paper with Einstein. I just
wish I could have been, you know, I wish I could have been a lizard on Einstein's desk and just whispered a couple of little things to him just to see if I could have got him to think a little. Because I think he got too lost in his abstractions, you know, and he needed, because he sort of broke his own rule. By even imagining going the speed of light, he forgot that he was already going the speed of light. You know, that the matter in him was already going the speed of light. And if I think he would have thought about what really happens inside of an atom when you move it, how does the photons inside the electrons still move at the speed of light without going faster than the speed of light? You know what I'm saying? So
yeah.
I see that as like maybe just that might have been a critical error he made, is that he stayed with his metaphor, and his metaphor was really great for seeing some things, but it was an analogy. It wasn't the truth, you know. And so he kind of broke his own rules and then started saying, well, time dilates or this happens, and I'm saying, no, the matter changes. Okay, you didn't change time, you changed the matter. Because to make the matter go the speed of light, you've changed its configuration, you've changed its aging process, you've changed the orbits of its electrons. You know, and that's why it behaves.
Have you been working on that lately? I was
yeah,
watching
well,
your
you know,
videos.
I'm always fiddling with it, but I'm just saying.
It's similar to there's things in the sort of the quantum computing version of quantum mechanics now and stuff. It's similar, and there's people that work in like this cellular automata type of idea, where basically, yeah, I mean, motion is something tunneling. You know, there is a speed of light aspect to, or even instant, you know, to how things are moving, and it's not really. It's more like you make a perfect, like the way a wave moves. It's like the water stays there, and kind of the water next to it is pushed in to make a perfect copy of the wave that came there. And yeah, and I mean, I think that's the way things are going. But I mean, the specifics are always difficult because there's all these mathematical details to see if it matches up. But the concept, the philosophy of it, I think is winning.
I found one Feynman video where he says, well, who knows what the truth is, but I think, you know, if I was to think, then it all reduces to this checkerboard idea. And he actually said, you know, that's exactly my analogy, right? And so he actually said those words, and when he said those words, I said, okay, I can listen to this guy now, because he's saying just do the math, because he's.
Where is the checkerboard analogy right now in Gary's philosophy? I won't be able to find out since I can't listen to him in his current state. But where is it now, I wonder? Is there still a checkerboard with the tons?
Saying, I'm not smart enough to figure it out, you're probably not smart enough to figure it out. But he doesn't mean it's not figure-outable.
Yeah.
He's not saying there isn't an explanation.
Yeah, no.
He's not saying there's not an explanation for why there's this clock spinning and the vectors are decided by that, and you know what I'm saying?
Yeah.
He's just saying he doesn't know it, and if he can't figure it out, you can't figure it out, so just accept the math and don't try to figure it out. And I think it was underestimating people by saying that. I think it was, in a way, saying it the wrong way.
It's also a way to relax and listen to the data, right? It's not like you can't come back and go, here's the...
He was doing psychology instead of explicitly saying the truth, which was, this stuff's really small, we can't see what's happening, but there is something happening. Okay? It's not just probability. There's a reason.
Well, I've tried to explain that for years, as far as the physicists doing quantum mechanics. The fact that there's this chance and that they argue about the rolling of dice is kind of a big red herring, because they're not saying they have a theory where they're figuring everything out this way, and they're really resorting to statistics, and the statistics are, you know, as determinable, and the fact that there's always a 1 in a million freak chance doesn't mean you can't plan to drive into Inmendham and get some cigarettes. You know, I mean, you can make those plans, and yeah, there's a 1,000,000 chance that the sun's going to blow up on the way, but you know, and so the randomness they advocate is really so at the edges. It's not like the randomness of people that are saying suddenly you'll figure out something and teleport.
Well, I'm just saying that I think Feynman,
like the things don't have reasons. They're not saying things don't have reasons.
I'm just saying that yeah, I think it does all break down to something very mechanical, and that even forces are an illusion. That when you get to the basic mechanism, you're going to find that there is literally, okay, the electron is literally tied to the nucleus. That there's a string of photons or something else that's actually forcing the orbit.
Well, see, that's a very quantum
well, I'm just saying, unlike our gravity that looks like it's all invisible, what's invisible because we can't see any of this shit. Okay? But on the level of the frickin' atoms themselves, it's it's all mechanical structures. There's actual bridges.
But you
There's
use the word
actual,
mechanical, and it's more like fluid mechanics is the problem. It's not the mechanics
I'm
of
saying,
a watch.
no, I'm saying it's as
That's
rock
why you're
solid as a
wrong.
piece of steel. No, it is not fluid at all.
I think it's fluid dynamics, and that it's the
no,
same thing,
no,
though. Why
no.
can't you get certainty?
Fluid, you can't have fluid on a checkerboard.
Well, that's the weird. That's why quantum mechanics is so like impossible to understand, because there's this checkerboard, discrete, a photon's all alone, and then there's the wave mechanics
But
of
the
it
wave
looks like a
mechanics is
wave.
not a wave mechanic. The wave mechanics
Well,
is
wave mechanics is just
a
math.
property of the photon. The only reason why the quantum mechanics works is because there's this presumption that one photon is the same as another photon, and that's the lie. Every photon is different, and it's different in 16 or 17 different ways. You make up the number, it doesn't matter. But every photon has its own character. There's strong, weak, double strong, and that's why people are fucking up, is because they're doing quantum mechanics on the presumption that all photons are the same. And that's a big mistake.
They emphasize a lot about that, the sameness. They're all unique in some respect, but basically they're also very much the
Well,
same.
I'm just saying. I noticed that when I don't look. I can't do quantum mechanics, but I'm just saying when I did my analysis of it, that's the first thing that popped out to me was that there's always a presumption that there's no variable inside the photon. They're all the same, and all the variables have to come from the outside. That's where they're forcing the variables to come from, and that's the mistake, in my opinion.
Interesting.
Photons are changed by every interaction they have.
So well, I think your physics theories are kind of crazy, but I like your philosophy that leads you to do it.
Well, the last two slit, I did a two-slit video on the one channel. I did another one to sense it, but I pointed out that they do that little hole thing, where they have the gun here, shoots the photons through the hole, and then there's the two slits, right?
To mask
and so you would argue, what's this hole doing? All right, because the first obvious for me is that it's creating interactions. So you're changing the photons. That's changing the photons. The ones that are closer to the edge are going to be different than the ones that went right through the middle. And
well,
so that's well, I'm just saying that's your first filter. So now you've created a filter, and you're surprised you have a filtered result. Okay, filters create filtered results. And so you're filtering the photons. And as soon as you start filtering, then you're going to start getting bands. With every change. Well, anyway, I'm just, like I said, I don't want to do that. I'm saying I'm getting close. That's all I'm going to say. I think I'm getting close to something. It might be bullshit, but it looks like the pieces are, I got like a piece here, and I got a piece here, and I'm seeing something. I'm seeing a connection.
Well, you could always, I think there's a lot of stuff still to discover by taking a philosophical approach. I mean, that is how Einstein broke it down. Going back to this basic.
I'm cheating on Einstein.
And it's very much philosophy
at that point.
And I'm cheating
on Einstein, right? Because what got me to thinking about it was the fact that this stupid Einstein metaphor, of traveling on a light beam.
Yeah.
And I said, of course you can't do that, because my matter can't do that.
Yeah.
And why can't matter do that? Because matter's already moving at the speed of light. It was such an obvious answer. Right? I mean, it seems obvious, right? It's already moving the speed of light. How the fuck can it possibly go the speed of light when it's going the speed of light?
Well, it's funny because I don't believe my own thoughts on this per se, but I've always had some idea that, E equals mc squared means that you captured this energy, and energy still wants to be moving in this infinitely smooth,
well, let's say it has
slippery
to.
way.
Say it has to. Let's say it has to move. It doesn't have a choice. The light must always move, and the only thing you can do is catch it.
Well, in quantum mechanics, it's kind of like that. Everything's moving like that, but there's a standing way.
Catch it. All you have is one thing. You have photon.
Well, and like the electron is that. It is a thing that gets caught, and it is moving
around.
Right,
and the electron, imagine the electron as a double helix. Okay, so we can use the double helix again. Imagine the electron just made out of photons on a double helix. So the photons are moving the speed of light, but at the same time they're spinning. Right? So the faster they spin, the slower they move. Right? The slower they spin, the faster the electron moves. Right. So the speed of the electron is dictated by the spin of the photons inside.
Well, this is interesting. I don't know if Gary has abandoned this. I had forgotten this idea of his. So I knew someone in my past also that had this theory that, hey, maybe it's this spiral thing. And you can definitely graph a photon as a spiral thing because it's two perpendicular things. Well, for example, you can have what do they call it? Circular polarization. Is it circular polarization? Where the polarization isn't just fit, but it also rotates around. Now, the idea, if that rotates faster, you go slower. I get that metaphor. I don't see how it exactly applies to photons in terms of denying relativity. But if you go ahead and obey relativity, where when it spins faster, things just look slower so that it turns out to be the same forward speed, you could probably have an equivalent theory. That made sense.
To me, it's a perfect explanation of the variable speed of electrons.
Yeah. That's interesting because you could do some math with regular physics to that because the electron has a wavelength. You could figure out how much. Well, you need to figure out like what the size, the geometry of that little of the
and the wavelength could be the axes on the helix.
Well, it's the wavelength would for sure be
helix,
how fast it's spinning, right?
Exactly, but I'm just saying the helix.
If it has a really fast thing, then that means it's
the helix has this automatic. You know what I mean? Mm-hmm. It can tend to have an automatic wavelength built into it.
Yeah.
You can have a helix that has nodes, and it has the wide, the amplitude node and the narrow node. So you could have the wavelength built in. So you could have photons of infinite wavelengths, variable wavelengths, built into a physical structure that will force them to break at certain wavelengths. So when you exchange photons, a big one could come in, okay, and you pop out a little one.
You should write a simulation, a JavaScript simulation to visualize.
Yeah, exactly.
Because that is the other thing that's kind of cool. I mean, when we were kids, they were still saying that there isn't geometry to the atom. Just stop thinking about that. Now they're back to, the molecules have shape and they wiggle and they're little gel.
But this is the problem. I mean,
they have geometry again. They have sizes.
Look what they've done to the Standard Model, though. They've turned it into this preposterous thing where they've included into it a bunch of things they've discovered with these stupid accelerators. The particles that only last a .0, Planck constant in time. That's how long they survive.
Yeah.
So they're so eccentric and so unnatural. And yet they're considering them natural products. They're considering them natural.
Well, just because they predicted they'd see. But here's the thing about this. Gary often says this. That wasn't a real experiment. That was the exception. Yeah, we often build experiments that show the exceptions, the part that defies current understanding. You can't say that's not a natural product when it happened in nature. Saying it was the mistake is saying, well, it's just a thing that only happens a little bit of the time. Yeah, and then they calculated that low probability and showed that this low probability thing they've not seen before happens. That's how the demonstration is being performed. See that if they were right about how stuff worked.
Well, no, they're not doing it that way. Yeah, okay, they're doing that based on the same presumptions of all photons are the same and all mass has to equal energy and all that kind of stuff. So they're just doing it by.
I hadn't remembered we talked about science.
The crudest standards. What I'm saying though is all they've done is broken things and created unnatural lengths of electron. You know what I'm saying? Lengths that could never exist in an atom or in nature.
Well, but they've explained that. They're
well, I'm just saying they've broken, the mechanics, and then said the part is a real part, and it's not really a real part.
No,
it's an eccentric part that they've created by exploding the damn thing. I mean, obviously the bumper always flies off the car in one piece. Doesn't mean that the bumper makes the car move.
Yeah. No, there's an argument to that. The thing is, they have pieced everything together so well. You do have to contend with the system.
They only pieced it together so well is because they forced it to piece together.
Well, not
so
entirely.
Well.
I mean, for example, with the LHC, it's killing all these superstring theories. They're all dead. Because they predicted particles they weren't seen. But the standard theory just predicted one particle left that hadn't been seen, and they've seen that. So whether it's a particle or not, and that's a confusion or not, it's still true that they don't always get to see what they want to see. I mean,
Well,
like all these string
I'm just
theorists
saying,
are fucked now.
all they're saying is
You have supersymmetry, you remember that?
Yeah.
That's what every physicist thought 30 years ago. They were all getting on board, and now those supersymmetry theories, none of the particles that they predict
it's all
have been
made
seen.
out of the same crap, and so I'm just saying if I say a photon is like say
See, the point here is that the standard theory had one particle that hadn't been confirmed to actually exist. The LHC confirmed that. Whether particle is the right word doesn't matter. It predicted it at a certain energy level, and then it saw what it predicted in those terms, and so it was confirmed. That means the standard model has another gold star after antimatter, all kinds of gold stars. Supersymmetry and predictions of string theory where it was worked up to where there were predictable results, those didn't show up. So, it's not a gold star. It's a black mark, right? So science does progress, and there is a difference. It's not all made of the same shit.
it's like I like using the ring example. Okay, magician rings, they're locked together.
Yeah.
So electrons could have an open end, and one end overlaps the other.
Yeah, the Higgs boson was the last.
Yeah. So it runs into something.
The last
right
thing in the standard
model.
model.
So it's a mechanical bond, between the two electrons that way, because now they're hooked inside of each other and they can't escape each other unless they're exactly the right point.
Because there's this weird thing with electrons and pairing and.
So I'm just saying that they take something like that. They take this two rings and they throw it through this accelerator. And what I'm saying is all they're getting is broken pieces of electron. Yeah. They're not getting a real particle. They're getting the mechanics.
I understand what you're saying, but see, this is why I like wave mechanics, because if you're saying everything is wave mechanics, then yeah, when you throw when the wave's coming and you splash it away and make it away, you get splashes of water, and you can't say that that's really that much about the wave. And so it's a similar kind of an argument. Like they're calling it an unstable piece just because they haven't ever got a smaller piece.
Well, and the reason why it has to disintegrate.
But it still means that like the ring is made of that thing in some sense. Like that's the material, that's the metal.
It can never exist as half a ring. Okay, it can never exist as half a ring. So that's what I'm saying is once they break it, okay, it has to reform into a ring, or it has to disintegrate, but it can't maintain itself in the condition you put it in.
Yeah.
And that's why I'm saying
that. Well, they just express that as
I'm just saying,
instability.
yeah, I know, but they're not. What I'm pointing out, what I'm attempting to point out, is that it's not, in terms of modeling an atom, this isn't the real part. Yeah. Okay, it's like.
So that was a nice old way to go ahead and converse with Inmendham. Anyway, it's funny when IRL is the fantasy. Okay, there were definitely some things I wanted to say about that. I started thinking, with the Huygens principle, I think actually when the wave is traveling like this, those ripples that you take in principle with the Huygens principle, they're sending a wave backward. The reason that you don't see it is because there's a wave coming forward. That wave backward is what is canceling out the wave behind it. So in a way, with the Huygens principle, it happens to be moving in this direction. And so the propagation forward actually cancels out what was behind, or else it would actually travel in that. If a wave hadn't come from this direction with the Huygens principle, that wave is traveling backward. But the reason it doesn't seem like that is because the wave coming forward is exactly half out of phase with the wave going backward. Pretty sure about that. But I got to run through the actual math of it. But I think that's because I was trying to think, why doesn't the wave propagate backward? And the fact is, it does, but the end result is a wave propagating forward.